Yeah, hi there. In this tutorial, we are going to cover discretization. So, data discretization is the process of converting continuous data into discrete buckets by grouping it. Discretization is also known for easy maintainability of the data. So, training a model with discrete data, it becomes faster and more effective than when attempting the same with continuous data. Although continuous value data contains more information, a huge amount of data can sometimes slow down the training process of a machine learning model. So here discretization comes handy. But the main challenge with discretization process is to choose the number of intervals or the bins and to decide the width of each bin. So basically what we do in discretization, we have a variable which is continuous in nature and we are converting it into a categorical type of a column where we have different bins and each bin has a specific width. And so let's take an example. Let's say we have a way, we have calculated, we have gathered weight of people, and we want to convert this weight column into the categorical column, that is we want to discretize it. So how do we do this? We can create a range for each of the category. Let's say we have different categories like underweight, normal weight, overweight. Let's say three categories we have, and for each of the category we specify a range. So basically so that range becomes a bin width, and based on each based on the weight of a person, uh, he will be categorized accordingly into underweight or overweight or normal. And so in the end we have actually transformed a continuous variable into a categorical variable by having three different values or three different categories, that is underweight, normal, and overweight. So that was one example. Now let's go ahead and read the data from a file, student underscore bucket.csv. This contains student ID, age, grade, employed, and marks fields. Now let's say we want to discretize marks column of this particular data frame. So let's quickly first check the distribution of how it actually looks like. So there are 232 data points. Mean value of a marks is 58, minimum is 20, maximum is 98, and then the 25th, 50, and 75th percentile. So if I quickly plot the histogram of the marks, this is what it looks like. So now let's try to convert this into a discrete variable. So we have a function available in the pandas which is a cut function. So using that we can specify the number of bins that we want to create based on this continuous data, and we can also specify the label for each bin. So how do we do this? We say pd.cut, and x represents the data. So data is coming from df.marks, and bins is the number of bins that we want to create, which is 5, and we specify the labels, that is poor, below average, average, above average, and good. And we are storing the result in another field, basically creating a new variable, marks underscore uh, category, or marks underscore CAT categorical. And now let's check the number of data points that fall in each of these different categories, the one which we have specified. So this is how it is. Now if I just want to see the distribution in terms of a bar plot, so for this I'm just importing the matplotlib library, matplotlib.pyplot splt, and creating and writing a small function which is to draw the bar plot. To this function I'll pass a specific column, and for that column it will create the value counts, that is the number of data points for each of the categories, and then it will plot that bar plot in which the x-axis will be the index, that is the labels, and y-axis will be the number of data points which fall under that particular category. So this is our custom bar plot. So let's say we have created one categorical variable, marks underscore CAT. So let's plot this. So this is how our data now looks like. So from the marks, the distribution was this. Now we have created a new variable which is marks underscore categorical, and now the distribution has completely changed into this. And if you want to see first few records, so we can see the marks was the original column, and we have a new categorical column, which basically we have discretized marks column into marks underscore cat, like this. Now another method is using the same pandas dot cut. What we can do, we can specify the bin. So instead of saying the number of bins as 5 and letting the function to decide the range of each uh, bin, so we can specify the width of each bin by ourselves. So in this way we get a more control, like how much wider or narrower we want a particular bin width to be. So how do we do this? pd.cut and access the data. Bins is I'm specifying the range as this: 0 to 30, 30 to 50, 50 to 60, 60 to 80, 80 to 100. So the marks between 0 to 30 should be categorized as poor, between 30 to 50 as below average, between 50 to 60 as average, 60 to 80 is above average, and 80 to 100 is good. So now this is the custom width of the bins that we are creating. And if you notice that this is not equal, so we have a difference of 0 to 30 and 30 to 50, 50 to 60. So this is, so it is not necessarily that you pass the equal. It again depends upon the type of the variable that you're dealing with and what is the business rule that you want to apply. So we got this marks categorical data. So now see, the distribution earlier was more or less kind of a symmetrical. Now this has completely changed. We have above average, below average, good, poor, average. So we have a lot of students who have scored above average, followed by below average, then good, then poor, and average. So next is we can create an equal with discretization. So what it means is basically we take the maximum value and the minimum value and find the difference between the two, and we, whatever the difference that comes, we divide it by n, where n is the number of data points. So what it means, each width that we get will be of equal range, and that's how we create the category. So we can use one class which is available in sklearn.pre-processing, that is called as k-bins discretizer. So I'm importing it from sklearn.pre-processing, import k-bins discretizer. Now just creating an object of it. The object name is discretizer, and object is of class k-bins discretizer. Now I want 5 bins because that's how I want our marks to be categorized. So number of bins is 5, and by default is also actually 5. And in code I want is ordinal. Basically I am specifying an ordinal category. So that is why in code is ordinal, and the strategy is uniform. That is, I want uh, uniform means that is the equal width for bins. So the object is created. Now we have to apply dot fit underscore transform function or method on this object. So we see discretizer dot fit underscore transform. Now we pass the data actually in the form of two-dimensional array. So what I'm doing is df, which is the data frame, and selecting the marks column, converting it into values, that is array, and just reshaping into -1, 1, that is n number of rows, and one column. So that is, it will create a two-dimensional column, and whatever the output comes, it will be in the form of 0, 1, 2, 3. Basically it creates different categories in the numerical format, because I've given the value as 5 for the number of bins, so it will create value from 0 to 4, and I want those values to appear as integer. So that's I'm specifying dot as type is integer, and storing the result in a new column as marks underscore uniform discrete. Now if I display, this is how our data looks like. I'm just displaying the first few records. Okay, so this is what we created earlier with pandas underscore cut. This is what we created with pandas cut again, but with our specific category, with our specific range of each category. Now here it is the based on the uniform discrete values. Basically the bin width is uniform, that is equal size of each bin width. Now again, I'm just plotting this new column that we have created. So if you see, this is how it looks like, the number of data points falling in different categories, 0 to 4. Now if I want to see what is the uh, width of each of these bins, so we can say discretizer dot bin underscore edges. So the first this is the first bin, and it is having width from 0 from sorry from 20 to 35.6. The second is 35.6 to 51.2, and so on. So that is one way to actually distribute the data into bins of equal width. Now another method is to distribute the data into bins, and each bin should have equal number of data points. So the width can vary, but the number of data points that fall in the each bin should be the same. So that is called as equal frequency. So it's the same thing. We have to create an object discretizer based on this k-bins discretizer class. Number of bins is 5. Encoder is ordinal. Now strategy will change. Now, earlier the strategy was, if you see, um, uniform. Now from there it is changing to quantile. What it will do, it will create bins of different widths such that the number of data points in each bin should be equal. And then I'm just calling discretizer.fit underscore transform, passing the data frames marks column in the form of a two-dimensional array, and finally whatever the values of the categories it is coming in the form of numeric data, I'm converting it into integer and storing it in another column called as marks equal frequency. So this is how it looks like. This is a new column, and if I plot it, so if you see, because it is equal frequency, it means number of data points in each bin should be more or less equal. So this is why you see all these have equal length, that is equal height for each of these categories. Again, we can check the um, range or the bin width for each of these bins using discretizer.bin underscore edges underscore. Now, next method is k-means discretization. So k-means discretization means we are applying k-means clustering algorithm to the continuous variable and thus dividing it into those k groups. So k is the value that we specify. Let's say we are specifying number of bins is 5. Encode again is ordinal and strategy is k-means. Rest of the things are same like we did earlier. This time we are just storing the result in another variable which is marks k-means discretization, and we getting the value like this. So if I plot it, so it looks like this. So these are the different categories it has created, and the number based on the number of data points which fall under which category, we are getting the height of each of these bars. So the conclusion is that we do this discretization process to reduce the signal to noise ratio. That is, whenever we discretize a model, we are fitting it to bins and reducing the impact of a small fluctuation in the data. So often we would consider small fluctuations as noise, so we can reduce this noise through discretization. So this is a process of a smoothing wherein each bin smoothens the fluctuations, thus reducing noise in the data. And then we do this because certain models may be incompatible with the continuous data. For example, the decision tree models, random forest, they are not suitable for continuous features. They work well for the categorical kind of a data. So that's when also when we have to convert a continuous variable into a discrete variable. And next point is, often it is understandable to convert a continuous data into different categories so that it makes more business sense. For example, like the weight example we have taken earlier, to convert weight into, let's say, three categories: underweight, normal, overweight, and specifying the range for each of these categories. So this is what the discretization process is, to convert the continuous data into the different categories. So each category will have a label, and it will have a bin width which specifies exactly the range. That is, if a data point falls within this range, then it should be labeled X. If a data point falls within this range, it should be labeled as Y. If it falls in this range, it should be labeled as Z, and so on. So that's how we convert any continuous variable into a discrete variable, or that is the discretization process. So that's it in this tutorial. Thank you.